Hello everybody, today we are going to be doing this SAT problem by hand. I already showed you how to do this problem in Desmos, but now let's go over how to do it by hand. Desmos is available to everyone taking the SAT because the SAT at this point is fully digital, okay? It's really important, I think, to be able to use Desmos as well as do it by hand. If you forget how to do it by hand, you can do it in Desmos. Forget how to do it in Desmos, you can do it by hand, okay? Let's jump right into it. So this problem reads, in the given equation B is a positive integer. The equation has no real solution. What is the greatest possible value of B? Okay, so the key for this one is no real solution, okay? And we're looking for the greatest possible value of B. So what we're going to use to do this by hand is something called a discriminant. So this here is from my SAT workshop that I teach. So what we have up here is a quadratic equation. It's in the same form as our problem up here. The numbers in front of the x's are so-called coefficients, and that's what we're going to be using in this problem. Now, this problem specific is a no real solution problem. So the discriminant equation we're going to use is this right here, okay? So b squared minus 4ac has to be less than 0, and it's no real solution because the parabola is not going to intersect the x-axis, all right? So we're going to be using this equation, so I'm just going to go ahead and copy this, and you can take a screenshot of this sheet here, because if the problem is asking for exactly one solution, this is the equation for the discriminant, and then two real solutions, the discriminant has to be greater than 0 or a positive number. Okay, so let me just copy this, and we'll work on the problem. Okay, so here's the discriminant. So the way we're going to do this, some students have trouble pulling the coefficient, so let me rewrite it here. Bx plus c equals 0. So the coefficient is that number in front of the x. So here it's just a negative, which is going to give us -1. So a is -1. And then we've got b, which we're looking for b, so we don't actually have b. So b is just going to be b. And then we've got c, and c is this right here. Don't forget to bring in that minus. It's going to be a -676. So c equals -676, okay? And then we're just going to plug all these things into the discriminant. Okay, so we don't know b, so we're going to keep b squared minus 4. A is going to be -1, and then c is going to be -676. All right, so 4, so this is going to be a fully negative number. Whoops. 4 times 676. So this is going to be b squared minus 2,704. Oops, and that has to be less than 0. We're going to bring this number to the right-hand side, so we're going to add it to both sides. Plus, there we go. And so I'm going to rewrite this equation. Actually, I have some space underneath. It's going to give us b squared, this goes to 0, equals 2740. Now, in order to undo this square right here, what we're going to do is square root both sides, and that will get rid of that. They cancel out. There we go. So what we're going to have is b equals, and the square root is going to be 52. Oops, and you know what? I messed up the signs, you guys. This is something, and this is why I like using Desmos, because if you mess something up by hand, you can double check in Desmos, right? So this is telling us that b is less than 52, okay? Now, it's not saying b is less than or equal to 52. It's less than 52. And we're looking for the greatest possible value of b, and b has to be a positive integer. So b, the greatest number b can be is 51, okay? So b is equal to 51. And that's the answer that we found in Desmos, but this is how you would do this problem by hand. So let me know if you guys have any questions. And like I said, in all my tutoring sessions and my SAT workshop that I teach, I show students how to do everything by hand, as well as in Desmos. You can use either method when you sit for the SAT. Okay, thanks so much, guys. Bye.